Hello, good morning, students. I am Dr. Sunita Tandon from RR College, Alwar. In the last 14 lectures, I have told about inhibition of enzyme catalyzed reactions. For revision, we can say that inhibition of enzyme catalyzed reactions, the inhibitors are of two types. First is reversible inhibitors and seconds are irreversible inhibitors. When we studied reversible inhibitors, then in that case we come to a point that there are further subdivided into three categories. Reversible inhibitors can be divided into three categories, subdivided into three categories: competitive inhibitor, non-competitive inhibitor, and uncompetitive inhibitors. Out of these, first of all, we have studied about irreversible inhibitors. ठीक है. देन वी हैव स्टडीड द काइनेटिक्स. दो तरह के इनिबिशन है, रिवर्सिबल और इरिवर्सिबल. रिवर्सिबल के अंदर अगेन तीन पार्ट है: कम्पिटिटिव इनिबिटर, नॉन कम्पिटिटिव एंड अनकम्पिटिटिव. And second is irreversible inhibitors. Then we have studied the kinetics of reversible competitive inhibitors. ठीक है, we have studied about the graphs and various equations about this. Then second, we have studied in the last lecture about competitive inhibitors. Now today we are going to start with non-competitive inhibitors. In this case, we have non-competitive inhibitors, and now we are studying uncompetitive inhibitors. In this primary plot between 1/r and 1/s, कल हमने देखा था कि दो तरह के ग्राफ्स होते हैं, प्राइमरी एंड सेकेंडरी. प्राइमरी प्लॉट इज बिटवीन 1/rate and 1/substrate concentration. It comes out to be straight line with a intercept of 1/r maximum and slope comes out to be km, Michaelis Menten constant, into bracket में 1 plus I upon ki divided by r maximum. And secondary plot is between slope and I, inhibitors concentration and slope of the primary plot. When we plot a graph between them, again we get a straight line with a intercept of km upon r maximum, and this is equal to I. Today we are going to study the uncompetitive inhibitors. In this primary plot between 1/r and 1/s, as in case of earlier part of the lecture, gives straight line at different but fixed concentration of inhibitors. This plot is a primary plot of uncompetitive inhibitor, like in case of हमने देखा था ना प्राइमरी प्लॉट ऑफ नॉन कम्पिटिटिव, कम्पिटिटिव. ठीक है, in this case this plot is a primary plot of uncompetitive inhibitor and is considered to be the exceptional characteristics for identification. In this case, we get only intercepts effect, but not the slope effect. Not the slope effect. You can see in the diagram 1/r and 1/s. When we plot it 1/r against 1/s, ठीक है, we get primary plot, and these plots are forming intercept at three different points, and three different points, they are the three different fixed concentration of substrate, and they are extended to the negative side of the curve. Then mechanism shows that enzyme react with substrate to form ES. This with I inhibitor combines to form K dash I, new rate constant K dash I. Then this ES and I मिलके complex बनाते हैं ESI, and alpha या gamma for this reaction is equal to V maximum into concentration of substrate upon Km plus alpha into concentration of substrate. Therefore alpha comes out to be 1 plus I upon Ki, K dash I. This is a primary plot. This helps in distinguishing uncompetitive inhibitors from those of competitive and non-competitive inhibitors. R is equal to R maximum into substrate concentration divided by 1 plus I concentration divided by Ki. This is first part of equation in the bracket. This is divided by substrate concentration plus Km upon 1 plus I concentration divided by Ki. The double reciprocal form of this equation gives 1 upon rate is equal to Km upon R maximum, 1 upon substrate concentration plus 1 upon R max bracket में 1 plus I concentration upon Ki. From this equation we get the slope is equal to Km upon R maximum and intercept is equal to 1 upon R maximum in plus I upon R maximum into Ki. In this case of the secondary effect or the second 2-degree plot for uncompetitive inhibitor. 2-degree प्लॉट में इंटरसेप्ट को स्लोप के अगेंस्ट प्लॉट किया गया है एंड वी हैव गॉट अ स्ट्रेट लाइन एंड आपने इंटरसेप्ट को इनहिबिशन कंसिडरेशन के अगेंस्ट प्लॉट किया, जो कि हमने अभी तक ऐसा प्लॉट नहीं बनाया जिसमें इंटरसेप्ट को आई के अगेंस्ट प्लॉट किया हो. In this plot, we get intercept of I is equal to R maximum and slope of 1 upon R maximum into Ki. Rate equation for non-competitive inhibitions. Now we will study about the rate equation for non-competitive inhibition. In both the enzyme and enzyme substrate complex bind inhibitors, the following model results E plus S with a rate constant of K1 and reversible rate constant K2 form E into S complex. रिवर्सिबल है, बनता जाएगा, ब्रेक होता जाएगा. ES with a rate constant of K3 converted into product and E is regenerated. Again, ES complex combines with I to form a 3-body product ESI. This ESI doesn't go to form any product or there is no reaction. From ES to ESI, rate constant is K dash I. From ESI to EI, substrate concentration S with a rate constant, reversible rate constants, it is converted into EI. This EI then again with the rate constant of Ki and with combination to leaving I, it is converted into E plus S. Both of the inhibitors bindings steps are assumed to be at equilibrium but with the different dissociation constant. Though both of inhibitors binding step, 2 steps are inhibitor binding steps. First is with the rate constant K1I and second is in a inhibitor binding step is Ki. ठीक है, Ki and K1I. Both of inhibitor binding steps are assumed to be at equilibrium but with different dissociation constants. First, Ki gives E into concentration of A, concentration of I upon concentration of Ei. This is equation number 1. Or in this case, Ei is equal to E into I if we apply set steady state concept. Similarly, K1I is equal to Es upon I concentration into I concentration upon ESI concentration, equation number 2. This phenomenon is alternating, called as mixed inhibition or non-competitive inhibition. The conversation condition for this relation scheme is first ET gives you E plus EI plus ES plus ESI. Put the value of 1 and 2 in equation 3. 1 is equal to Ki EI upon EI. Then we get ET is equal to E. I की जगह क्या आ जाएगा? इसकी जगह फर्स्ट इक्वेशन में E के बाद EI है. EI की जगह क्या आ जाएगा? 1 plus I concentration upon Ki plus ES into 1 plus I upon K dash I. Equation number 4. Or ET is equal to E and alpha we have seen that we have used term alpha. ठीक है, अल्फा किसके लिए हमने यूज़ किया है? अल्फा जो हमने यूज़ किया है 1 plus 1 I dash upon 1 upon K1I. We can write this equation ET is equal to E alpha plus ES alpha and alpha dash, and this is equation number 5. Here alpha is equal to 1 plus I upon Ki, and K alpha dash is equal to 1 plus I upon concentration upon Ki. Apply steady state condition for ES, we get d by dt of ES is equal to K1 E into S concentration minus K2 into ES concentration minus K3 into ES concentration is equal to 0. Or K1 ES is equal to ES concentration into K2 plus K3 concentration. This is equal to E or is equal to K2 plus K3 into ES upon K1S. Next, E is converted into K2 plus K3 upon K1 and ES upon S concentration, which is divided by K1. In the next equation, E is equal to Km ES upon S. Km ES upon S alpha is equal to S alpha. From equation 5 and 6, put value of E in and take common. Then ET comes out to be ES bracket में alpha Km upon S plus alpha dash. As we know that R is equal to K2 into S. This is rate equation is equal to K2 into S. Therefore, rate is equal to K2 into ES की जगह हम लिख देंगे equation 7 से ET into S concentration divided by alpha Km plus alpha dash S. Then dividing by K2 ET, R maximum we can get. R is equal to R maximum S concentration upon alpha Km plus alpha dash CS. This is equation number 8. Next part of this derivation and kinetics we will study tomorrow. Thank you, students.